Hello and welcome everyone to this evening's meetup. I'm happy to see everyone with us today. Today we have Deepu. He's one of the co-leads from JHipster, and he also works for Okta. He's based from the Dutch community, from the Dutch Java community around. And Deepu has been also helping out with the Fuji tour. And Deepu, thank you so much for being here with us. I just want to say two words about Fuji. Fuji is it's a new community place. You can go there to learn about all the JDKs. You can see what's new. You can read blogs and many other stuff. Visit fuji.io and stay updated on all the new developments that's happening on Java. And especially thanks to everyone at Fuji that's been helping us with the Fuji tour, and we had some great speakers. My name is Darvish. I am one of the organizers from javaBin. javaBin is the Norwegian jug. We have regions around the country. We have volunteers that organizes meetups, conferences, and events. And if there's any question about javaBin, please just let me know. For today's meetup, you can use the comment field in the YouTube channel, and I will make sure to read them out to Deepu when we have completed the meetup. So that was my very short introduction. Deepu, the stage is yours. Thank you for being with us.
Yeah, thank you, Davis. Thanks for the nice intro. So yeah, let me share my screen. Yes. So hello, everyone, and welcome to the talk. So today we are going to look at the state of pattern matching in Java. So before that, introductions. My name is Deepu K Sasidharan. I'm the co-lead of JHipster, as Davis mentioned. I also created a nifty dashboard called KDash for Kubernetes. If you're into Kubernetes, check it out. It's written in Rust. I'm an open source aficionado and a polyglot developer. I work as developer advocate at Okta with a focus on DevOps and languages in general. I also publish frequently about languages and tech on my personal blog. You can find it on deepu.tech. Please do follow me on Twitter if you're interested in content I produce. I have also written a book on full stack development with JHipster. If you like this talk, you might like the book. So if you are into JHipster or full stack development, maybe check it out. So let's get into the actual talk. So what exactly is pattern matching? As per Wikipedia, it's the act of checking a given sequence of tokens for the presence of the constituents of some pattern. That sounds very confusing, right? Like, simply put, it's a language feature where you can test for a specific pattern on a character sequence or a data structure. I think most of us, I think all of us would have done pattern matching. So it can be classified into two types. The first one is matching for sequence patterns. This is pattern matching on character sequences or strings, also known as the beloved regular expression. So all of us would have done that. I still wish I could write regex without cursing and looking up the syntax like every 2 minutes. It's one of the most complex piece of technology ever invented, in my opinion. The second is tree patterns, which is testing for patterns on a data structure. And this is what we are going to talk about today. We're not going to spend time talking about regex. I think there's been enough said about regex, right? So nice. Before we go into pattern matching and look at the details, let's see, why do we need pattern matching? We don't, to be honest, as pattern matching is not a requirement for a good language. Many of the most popular languages like JavaScript, Java, and Go get by just fine, without pattern matching. but still it's a great feature to have due to the advantages it offers. It's like really good to have. You can survive without it. You can perfectly write good code without it, but great to have, to write even better code. First and foremost, it reduces cognitive complexity. Hence, it's much more concise and readable. Complex logic can be written using fewer lines of code. While fewer lines of code is not exactly like a required benchmark, it's still good to write stuff in fewer lines of code when possible. It is also simpler to write and maintain. In a language like Java, it could also reduce reliance on reflection and casting to an extent. It can also help to avoid bugs caused by pattern dominance and pattern non-exhaustiveness. So pattern dominance is when a previous pattern supersedes another, making it unreachable. A modern compiler should be able to catch it, especially on a language that supports pattern matching. Pattern exhaustiveness is when the compiler warns you when you have not checked for all possible variants of a type in a switch case or something like that. It's like having a case for all enum values or all subclasses of a type and so on. Of course, these advantages depends on how a language implements pattern matching. So later we will look at these from the perspective of Java. But before that, let's look into a few more things. So languages that have great support for pattern matching would have these features. It's not an exhaustive list or anything, but more of a generic expectation based on the most popular languages that have pattern matching. These are also so that the previous advantages we saw can be fulfilled. So matching enum values is something most languages, including Java, already does. So that's a requirement. Matching values in switch and if statements are also common in any Turing complete languages. Another required feature would be to match for a data type in switch and if statements, not just values, but also for the data type. It would also be nice if we can do variable assignments as a result of such pattern matching. Of course, matching for null would be required in a language like Java that has the concept of null. If you can match for data types, then it is logical to expect refining the pattern further and using the match type as a type guard, right? To refine further and do further matches on values or particular data structure or whatever. We already saw what pattern dominance and pattern exhaustion is, so of course it would be nice to have support for those. And advanced pattern matching would also require the ability to destructure data types and look for partial or nested matches within them. So these are the kind of expectations that someone would have when you hear, hey, this language supports pattern matching. So these would be what I would expect also when I hear, hey, Java has pattern matching, right? Again, before we go into Java, let's look at some examples of pattern matching. So these are some of the languages that has great support for pattern matching. Rust and OCaml is kind of leading the pack here in terms of the most features supported. On the JVM world, Scala offers most of these features as well. So let's see some examples so that seeing examples in other languages would help us compare and understand where Java is currently, so that we can appreciate what we have. Here we see an example of destructured partial patterns in Rust. So you can see the point struct has been destructured here. This could have been a nested pattern as well, and Rust supports all of the features that we spoke about earlier. In Rust, pattern matching is used for almost everything, from error handling to handling monads to functional logic and so on. Here's an example from Scala with a partial deconstructed match on a case class. Scala also supports type guards, type exhaustion, and so on. I think Scala is one of the JVM languages with the most feature complete pattern matching. Here is another example from C#. Here we see destructuring, pattern refinement, null checks, everything in a switch statement. Now, so that now that we understood what pattern matching is and we have seen examples and everything, now let's get back to Java. So let's see what Java has to offer. Unfortunately, Java is still a bit behind the curve when it comes to pattern matching compared to all these other languages that we saw. But fortunately, we already have most of the building blocks required to achieve most of the features we saw earlier. So we already have switch statements like forever. We also have switch expressions from Java 14 onwards. As compared to switch statements, switch expressions can return a value, can have multiple case labels on the same line, and they also need to be exhaustive. And hence, switch expressions can be used for variable assignments and statements without fall through and so on. So this helps us to achieve some of the features that we saw earlier. The instance of operator can now pattern match data types, which is a great improvement. Which means casting after an instance of check is no longer required, and this can be used in if statements, assignments, and returns. Right? With Java 17, we have two more building blocks which are very important. So number one is seal classes, and number two is the first preview of pattern matching for switch statements. We will look at these in detail a bit later. But first, let us look at some examples of what is already possible to do as of Java 17 when it comes to pattern matching. So from Java 16 onwards, we can do pattern matching using the instance of operator. It can be used on if statements, and we can use it as a type guard on variable assignments and returns as well. This lets us use a variable without casting it further after type check, as I mentioned. This is a new syntax added to the language, as you can see. Here, in this particular example, we see pattern matching using the instance of operator, right? The operator is followed by a type and a variable name, as you can see. So object instance of string, that is like the old syntax of instance of. The new syntax is object instance of string followed by a variable name. And we can access the variable without any further casting. So as you can see, we can get rid of the line that casts it to a variable, because we can directly get access the variable s, within the type guard or within the if condition, which access the type guard here. Let's look at another example. So we can also use pattern matching as type guard in returns and variable assignments, right? See how much more concise the code is when we do the return using a type guard instead of the casting. In the first one, we have to do instance of check. Then we have to cast that into a variable and then do the actual checks. But in the second one, we can directly just do a instance of check and proceed to do any other checks or refinements, as that is what we call when we do pattern matching. So we are doing a pattern check and then we are doing pattern refinement right after it and returning something based on that. So which makes the code much more readable and concise, in my opinion. And here is an example for variable assignment as well. So you can use the instance of operator with the instance of operator with the ternary operator, so that you can do variable assignments as a result of pattern matching without having to do casts. So which is also nice, makes the code much more readable. I honestly hate seeing all those casts in Java code. Now let's take a look at a more realistic use case. We could do something like this if you want to, if you want to get a variable based on the type of a particular object, right? So we can do an if-else, if-else block, and on each line we can do an instance of check and do the logic, which is fine. This would work. This would already work in Java 16 and 17, but there is a lot of if-else, and if your logic, as your logic becomes more complex, this will also become more, more, what do you call, more procedural, right? So it's a lot of cognitive load. And but with preview feature in Java 17, we can do the same in a switch case, instead of doing all those if-else conditions. So we can do that in both switch statements and switch expressions. This will let us rewrite the previous code using a switch expression, like how you see here. As you can see, this is also a new syntax, and it's a bit similar to the instance of operator without the particular instance of keyword, of course. This definitely has reduced cognitive complexity compared to the previous one, right? And the syntax is closer to most other languages with pattern matching. So you can take a glance and you can easily see what's being done. You can easily see the logic that is being done here compared to the if-else conditions. With this, the compiler can also warn us when pattern dominance occurs, as generic types should always come after specific types. So if you, which will not happen if you're doing if-else conditions. The compiler wouldn't warn you. If you, for example, if you check for a string before checking for a char sequence, the compiler wouldn't tell you anything. But in case of switch statements, if you do that, the compiler will warn you, because that then the char sequence is going to be vice versa. If you do char sequence before a string, then the string is going to be unreachable, right? Because char sequence is a enclosing data structure. Since this is a preview feature, the syntax might change in the future. I hope not, as I find this syntax to be quite nice, especially in Java. We can also do null checks in these switch cases, which makes pattern matching more complete and useful in case of Java. So look at these two examples. In the first one, you can have a specific case for null and handle whatever erases whatever logic required there, or you can also mix it with default or another case. And handle it that way. So this makes it easier for us to do more complex logic in Java without having to write a bunch of nested if-else conditions. As we saw earlier, type guards are already supported for instance of operator from Java 16 onwards, and Java 17 preview adds that for switch cases. So this means we can rely on the type guards to refine the patterns further to have conditions, relations, value checks, and so on. While it's not as flexible as in Rust or OCaml, it's still a good start, in my opinion. Look at these examples. Look at these code examples. In the first one, we are doing type guards using instanceof, because we are doing an instanceof check, and then immediately we can do an and we can use that particular variable and do further conditions. So you don't have to do any casting or anything there. You can just continue using anything. The only thing to keep in mind is you can only do and conditions, because obviously or doesn't make sense, in this context, because if you're putting an or, then you're not ensuring that there is a type guard for whatever type check you did. So only and conditions, of course, but right after the instanceof check, it has to be an and condition, and after that, within a brace, you can do whatever, like and or whatever with the actual values. So we can do any sort of and or checks. And in the second example, we do the same with the switch cases as well, which is excellent, right? Because normally you won't be able to do these kind of things in switch cases. Now we can check for a data type, data structure, then immediately do some logic on it, right? So that makes it very easy to do refinements. You can collapse a lot of nested loops, nested if-elses and stuff into single lines and stuff like that. So the code will be much more readable, in my opinion, and much more concise. So we saw about pattern matching for a while, right? Let's take a small break and look at another feature that was introduced in Java 17. So this feature has been finalized in Java 17. So this is like the final form. We now have sealed classes in Java, right? So what exactly is a sealed class? A sealed class lets you control which class can extend it. The same applies to sealed interfaces as well, of course. Permitted classes can be defined either as simple inner classes or in separate class files using the new permits keyword. If you look at the example here, you can see that you have a public abstract class called shape, which is sealed. It permits circle, rectangle, and square, right? You can also write it as inner class, of course. In that case, you would be defining the circle, square, and rectangle classes. So this is how you would define sealed classes. So a sealed class imposes 3 constraints on its permitted subclasses. First, a sealed class and its permitted subclasses must be in the same module or in the same package in case of an unnamed module. So if you are using module system, then it has to be in the same module. If you're not using the Java 9 module system, then it has to be in the same package. Second, every permitted subclass must directly extend the sealed class. So if you declare a sealed class and if you add permits something, class A, class B, class C, then all those classes that you add there as permitted classes must extend the sealed class. Otherwise, compilation will fail. Finally, every permitted subclass must use a modifier to describe propagation of sealing. So this is like a new modifier introduced. And the allowed modifiers are a final, which is an existing one, of course, sealed and non-sealed. A fun fact, non-sealed is the first hyphenated keyword in Java. So we don't have any other hyphenated keywords in Java. So what does each of these keywords mean for a subclass, right? So when you declare like a final subclasses cannot further be extended. Like that makes obvious sense, right? When you declare a class as final, it is final. You cannot extend it further. So you can declare a permitted subclass as final, and the class hierarchy ends with them. So you have sealed class, then you extend that with a permitted class, which is final, and the hierarchy ends there. That's it. Records are implicitly final and hence does not need the keyword. So if you're using record as a permitted class, then you don't have to use the keyword at all because records implicitly are fine. Then second would be a sealed subclass, right? A sealed subclass can further restrict class hierarchy with its own permitted subclasses. And the same three rules applies to these subclasses all over again. So a non-sealed subclass is the third type. A non-sealed subclass is a bit different. As the keyword suggests, it reverts to being open for extension by any class and hence breaks the class hierarchy rules set by the parent sealed class. So non-sealed subclasses are still valid children and works well with other concepts like pattern dominance and like pattern exhaustion and stuff like that. We'll see a bit more about that later. But these are the constraints imposed on subclasses, and these are the specific modifiers that needs to be used. So here is how it would look in practice. Sealed classes can also be used with records. They actually work very well with records. Here, the shape interface is sealed and it permits circle, rectangle, square, and weird shape as subclasses. So circle is implicitly final because it's a record. Square is declared as final, and hence both cannot be extended further, and the hierarchy ends there. So the hierarchy would be shape and circle, or shape, square. That's it. Rectangle is declared as sealed again, and it permits only transparent rectangle and filled rectangle as subclasses. Hence, rectangle's class hierarchy can extend further, and transparent rectangle and filled rectangle can even define their own hierarchy and extend it even further. So at this point, we only know that the hierarchy for these would be shape, rectangle, followed by transparent rectangle or filled rectangle, and followed by whatever they decide to do. Weird shape is declared as non-sealed and hence can be extended by any other class or record. So there is no restrictions. Here, the class hierarchy is wide open, and subclasses of weird class does not have to follow any of these rules of sealed classes. They can be whatever. All instances of subclasses of weird shape will also be an instance of weird shape, and hence any code that checks for exhaustiveness of subtypes of shape will still be valid. So it is perfectly fine to use non-sealed classes as subclasses, and all the goodness of sealed classes will still be available. A sealed class can be abstract and can have abstract members, and similarly, sealed interfaces can have default implementations and so on. There is that's all like standard Java rules. But abstract subclasses should be sealed or non-sealed and not final. So that obviously makes sense, right? So if you're defining a subclass as abstract, it cannot be final, right? Because a final class cannot be abstract. So trying to extend a non-permitted class with a sealed class will be a compile time error, which is obvious, I would assume. Another fun fact, if you are interested in algebraic data types and stuff like that, a combination of seal classes and records is nothing but algebraic data types, because algebraic data types are formed by combining others. They are the types formed by combining others, like tuples, records, and unions. So in this case, if you combine seal classes and records, they form algebraic data types. So you can do a lot of algebraic data type based stuff in Java now with Java 17. So that should be good news for a lot of people who are very much into algebraic data types. I'm not into that. So how does this relate to pattern matching, you asked, right? Because we were talking about pattern matching, and suddenly I took a U-turn and I was suddenly started talking about seal classes and stuff. It does have it does have something to do with pattern matching. So remember pattern exhaustion that we talked about. So the Java compiler cannot check for all possible variations for normal classes in a switch case or something, and hence would require us to do require us to add default case to avoid missing paths in a switch expression. So in a switch statement, default is not mandatory. So you can leave it and your logic will be wrong, of course, but compiler will not yell at you. But with switch expressions, default case is mandatory, because switch expressions does not fall through and hence must be exhaustive in Java. So that means you should have a default case if so that the compiler can make sure that the patterns are exhaustive or your checks are exhaustive, right? That does not apply to switch statements, like as I mentioned, because switch statements, they fall through. But with seal classes, the compiler knows exactly what the expected variants are, because we specifically defined the seal class and we said, hey, these are the classes that are permitted. So the compiler exactly knows what variants or subclasses are. We can use this for exhaustive pattern matching. In that case, the compiler will be able to warn us when we miss a variant in the check without having to add a default case and so on. This is much less error prone and clearer in terms of understanding, and it's much more concise. Even if subclasses are non-sealed, the compiler will still be able to do the exhaustive step. So that's not a problem. In the see this example. If you use the same seal classes that we looked at earlier, in the first example, we would get a compile time error as we are not checking all variants of shape, as there is no default case, and we didn't check for rectangle and weird shape, right? So this will be a compile error. In the second, however, there is no error even without a default case. As you can see, we check for all variants of shape. So the compiler knows all variants have been checked and doesn't yell at us about having to add a default case in a switch expression. If you remove the seal keyword for shape, then the second sample will have the same error as there is no default case and the compiler doesn't know about all the variants. So that is how seal classes and pattern matching can work together. So this is actually quite nice, especially if you're building libraries and if you're doing a lot of logic using pattern matching and stuff. Then seal classes can come quite handy. So based on what we saw so far, the state of pattern matching in Java is something like shown here. Most of the basic requirements are met, of course. These are the features that we talked about in the beginning, right? So most of the basic requirements are met with the instance of operator, and the Java 17 preview makes many other features possible. Of course, the type exhaustion only works for seal classes, and refined patterns are still quite basic, but the majority of features for proper pattern matching is already available with the preview. The only major missing parts are destructuring and partial nested patterns. So what does future versions of Java has in store, right? Let's take a look so that we know what to expect and where we would be. So Java 18 already has a candidate feature to add a preview for destructuring or deconstruction, whatever you like to call it. So destructuring, that is what it's being called in Java. I think in the JavaScript world, we call it deconstruction. So destructuring syntax for instance of operator is being added. So logically, at some point, that should extend to the switch syntax as well, because it makes sense. There also talks about improving the feature further to add support for primitives in switch case patterns, because currently switch case patterns can only work with non-primitive classes. There's also talks about adding ability to declare at a class level how it should be deconstructed, so that even normal classes can be deconstructed, not just records, because the suggested Java 18 the candidate Java 18 feature only adds destructuring for records and arrays, not for normal classes. So these are the things that are being discussed. At least the record patterns and array patterns is more concrete, because it has a JEP, it has a candidate, it is a JDK 18 candidate, but the other stuff are mostly just talk and mentions here and there, nothing concrete. So let's take a look at the concrete parts, the only solid thing so far, right? So that's like deconstruction only for instance of operator for now, not for switch cases. So see this example. If you have for example, like we should be with this, we should be able to deconstruct records and arrays. Of course, this is closer to a Rust example we saw earlier. Look at how the point is deconstructed to its members, and we can directly use the members with the type guard. We don't have to fetch the members, separately. You can declare. You can do an instance of check for the actual structure of point here, which is quite nice. Deconstruction can be nested as well, but doesn't have any facility for ignoring members like in many other languages. Because in Rust, for example, if I don't want a particular member, then I can just put underscore and it will be ignored. But in Java, unfortunately, you have to define everything if you're doing a nested reconstruction. So here you see an example for that. We have a colored point which holds a point and enum color, and you can actually do an instance of check for colored point where you already deconstructed the point and color, and since point is a record, you can further deconstruct that to its members. If point had another record, then you could even deconstruct that again. So you can go on. As long as you have records, you can keep deconstructing them. And then that means you would get newer variables for all the members, and you can directly start using variables. This is really nice, because imagine how many lines of code this will save if you have this feature, and how concise the logic could be when you start doing this. Of course, it would be really nice to have the facility ability to ignore members, because at some point it would be too many new variables declared and half of them not being used, right? So we don't want that. So it would be nice to have some way to ignore them in the future. I hope that will be added at some point. We can also deconstruct arrays. So array deconstruction is quite similar to array deconstruction in JavaScript. Thankfully, at least here, elements at the end can be ignored, right? Otherwise, it would be absolutely useless. So see how the string array is deconstructed to its first elements and with the Rust ignored, and you can directly access those elements. So nested deconstruction is also possible for mix of arrays and records. See how an array of points are deconstructed here, and yes, var should also work instead of the concrete type. So it's up to you based on your preference. Hopefully this would be extended to switch expressions and switch statements as well. And that would make pattern matching in Java closer to complete, with only normal classes, remaining to be accounted for. If the normal classes can specify how they should be deconstructed, that issue will be solved, and we'll have awesome pattern matching, which is almost comparable to like Rust or something like that in Java. So of course, it's a baby step and not as powerful as deconstruction in Rust or JS yet. But I hope we get there, and even this baby step would be great, and it would make pattern matching in Java much more powerful. As you can see, most of the features will be possible, and even the final pieces would be somewhat doable. So that is great. So to summarize, these are the current and future limitations as far as we can see. As of now, there is no deconstruction of any sort. Type exhaustion will only work for seal classes. Refinement is limited due to deconstruction limitations. More importantly, most of it is still a preview feature, except for the instance of operator and seal classes, of course. Which means adoption is going to be quite slow, right? Because nobody would want to use a preview feature in production. So as of Java 18, 6 months down the line, I think 6 or 5 months down the line, I lost track of when was it, please? Okay, let's say 5 months down the line. Some of these limitations will be removed, at least for instance of operator, I believe. So we probably would still have to wait, I don't know, maybe a year or 2 years, maybe, before we can actually start using full-fledged pattern matching in production. So I hope at least by maybe Java 20 or something, we have much more concrete pattern matching, which is usable in production. So that's it, folks. Again, so this being a preview feature or anything shouldn't stop you from trying the feature and giving out feedback. You can check out openjdk.java.net to find the JEPs and provide feedback to them. You can send feedback directly to the email address amper-dev@openjdk.java.net. So get involved if you're interested in seeing this feature, making it through and giving feedback and stuff like that. So that's it. Thank you for attending this talk, and feel free to reach out to me if you have questions later. You can also ask questions now, but later you can find me on Twitter, and hopefully I'll also publish a blog version of this, so you can also come and comment there if you have questions, suggestions, or whatever. So thank you.
Thank you so much, Deepu.
Hi.
Very great presentation.
Thank you.
It's nice to see your slides on the future of pattern matching and how it's actually going to be. There is a couple of questions that has come in. I will just take the last one over here. How is the performance of the matching? Is it quite efficient?
I didn't do any benchmarks yet for this, but from what I read through the JEPs, there isn't much mention of any performance impact, at least not for whatever we have for the preview. The deconstruction stuff, when it arrives, then that's something that I would maybe look for. Because that's something that it might have some impact, but at least for the switch case and stuff, I don't think there'll be any considerable performance impact when it comes to that. So.
And there is a question about something I have been also wondering myself really. What is the deal with having non-sealed? You can, when you want to seal interfaces, and you can mark the subclasses as non-sealed.
Yeah.
Why is Java allowing that?
I think there probably are particular use cases for that. I honestly couldn't think of a lot of use cases, but I'm pretty sure somebody thought of use case for that. What I can see is that, like, maybe for existing libraries and stuff, if you want to integrate, if you want to add seed classes, and if you already have classes which already have their own inheritance tree, and if you want to use that with a seal class tree, then without having non-seal, it will be very difficult, right? Because then the same propagation rules will be required, and all the existing stuff cannot be used. So that would probably make seal classes much more difficult to adopt. With this, so I'm looking at this as more of like a compromise kind of situation, where if you want to add seal classes into your existing code base, then you can start adding them, and whatever you cannot convert, you can have them as non-sealed and still get it working. And whatever you can add, like new classes and stuff, can be propagated with the default models. So I see of it as more like that kind of compromise, which makes sense.
Yeah. And having the switch expressions forcing the exhaustiveness in the cases there, and as far as I understand, having the non-sealed, you can still pattern match on the actual the type and on the type.
You can. You can pattern match until the type where you propagate it. Like, for example, if you can pattern match until weird shape, but probably not its subclasses, because then you're breaking that hierarchy. But you can pattern match until where you had that propagation. So before you broke the propagation.
Yeah. Deepu, I just want to ask you, what is your advice for people who consider upgrading to, or either cannot quite upgrade or doesn't know how to upgrade? What do you have any advices for people? How can they make use of the features, or actually get to 17 and start making use of these features?
Yeah, I would say so. Seal classes is finalized, so that's something that definitely can be used, especially for projects which projects of people who were waiting for some sort of algebraic data type support in Java. For them, I think this would be good news because we already have records, and with seal class we can now do algebraic data types, which is nice for them. So whoever is doing those kind of things, it's nice for them, so they can. So that would be one reason for them to switch to Java 17, so that they can start doing algebraic data types. But if you don't care about those kind of things, then seal classes probably is not that important to you. So then, and also for pattern, when it comes to pattern matching, using the preview feature in production is not a wise thing to do. So you can, of course, use the instance of stuff. So you might save some, like maybe you're not going to save lines of code or anything, maybe a few lines, maybe, but you can make it a bit more concise. It is finalized feature, so maybe you can start using that. But again, I don't see that as these features as something that you would want to switch for, unless you have those specific use cases. Of course, if you have use cases for algebraic data types, then it makes sense to switch to Java 17. But if not, then probably I would say, switch on your own convenience. Maybe switch to Java 11 first. So, and then switch on your own convenience. But then we also have all backward compatibility and stuff. So if you are planning to switch to Java 11, then maybe switching to 17 won't be that much of a bigger deal if you're already planning to do that switch, because between 11 and 17, I don't think there is any huge impact in terms of migration, right? So yeah, I probably wouldn't switch to Java 17 just for these features, because they are not concrete enough to make that effort if your project is huge. But if you're already in the migration for 11 or something, then I don't think it's a big deal to switch to 17. So,
and I personally like the fact that the switch expressions are built in a way that it doesn't really your old switch, the old way of writing the switch patterns, it's still the good old switch still works.
Yeah,
so yeah, I mean, and it allows actually for a good deal of refactoring. You mentioned this in your talk as well. You can, I mean, the benefit of refactoring and making the code more readable, more expressive is a huge deal. I have been looking into Haskell myself, and been looking at algebraic types. And in Java, there is other stuff that is also important, like the records allowing shallow immutability.
Definitely.
I mean, we don't have lazy evaluation out of the box natively, but having records and the benefits that records will bring, it will bring Java on the. What is your ideas about Java going more adapting the functional programming concepts that has been known?
Yeah, I think it's good. I mean, I'm not like a functional programming zealot or anything. I mean, I prefer to use the methodology that I strongly believe in using the right tool for the job kind of thing. So if something requires like procedural programming, then I'm going to do procedural programming. I'm not going to stick to, like, for example, if I'm writing something in Java which is performance critical, I'm not going to do functional programming, because it adds like Java is not a language that offers zero cost abstractions. So if I'm writing Rust, I would of course write everything in functional or whatever way, because there is no cost I'm paying. But in Java, if you go fully functional in a very performance critical stuff, you're going to pay performance costs for all the abstractions that you're going to use. So in that case, I'm going to write procedural or the good old if else for loops and stuff like that. But if you're not writing extremely performance sensitive stuff, then it shouldn't matter to most people. Then of course you can do all these things, and then these kind of implementations would be definitely helpful for those. So I wouldn't like to see Java going like 100% functional, or even the direction of Scala. I honestly don't like Scala. So I wouldn't like to see Java going in the direction of Scala, but it would be nice to see Java going in the direction of Kotlin, maybe. Make it more, making it easier to write more concise and readable code, getting rid of boilerplate, because one problem in Java currently is the boilerplate compared to many modern languages, the amount of boilerplate that we have to write. So it would be nice to have these kind of features like Switch, for example, Switch pattern matching in Switch when it comes out of preview, and if you start using it in production, it would make code much more concise, right? So it will avoid a lot of these boilerplate stuff. So I would like to see that direction. More language features that would let us write more modern code, less boilerplate and stuff like that. Maybe even a standard library like Go and stuff, that you can just do all this stuff out of the box. So that would be nice.
Great reflections, great thoughts, Deepu. I actually just also remembered I was checking Fuji the other day here and looking into OpenJDK 17. And if you go into the Fuji site and you look up OpenJDK 17, you will actually see that, and you can see an overview of all the issues, which is also fixed in the new release.
Oh, yeah.
So, I mean, for everyone who wants to have a better understanding of because I looked at some 2,000 issues that were added and fixed in the JDK, and I think that that's also one key reason to
definitely
updating.
Yes, and especially security fixes and stuff. Yeah. So absolutely. Yeah, definitely. Yeah, that would be nice. Realistically, yes, but we still have people in Java 8 who didn't migrate to Java 11. So yeah, so hopefully, soon.
Yes. Deepu, thank you so much for joining us today. Thank you so much for contributing and sharing knowledge with our community. Thank you to everyone who has been together with us this evening. That was it from us. So thank you so much, everyone, and have still a very good evening, and see you next time.
Good evening, everyone, and thanks for having me. Bye.
Bye.